Hello everyone. We'll be starting soon. Just wait for 2 or 4 minutes. Today we are going to learn about recursion backtracking. So if you have any idea what it is, just let me know. So do you have any idea what recursion backtracking is? It's a bit difficult, but we will be starting. Do you have any idea what? So it's a bit difficult, but we'll be starting uh, where we left yesterday. I gave you some practice questions, right? We will be moving on from there only. So did you done those questions? Have you done those questions? I left these questions. So do you have any idea how like if anybody have done, just let me know. Or if you have any idea which registrar structure we will be using, just let me know. Otherwise, we will start. Yeah, good, Manish. Function call inside a function is recursion. True. Yeah, there is two cases, base case and we have recursive case. Okay, so let me explain you what this problem is. Okay, so let's go. This problem states that you are okay, sorry. This problem states that you are given a string. A string is given to you, string is S. And you have to find the longest substring in that string such that no character repeats. So what does it mean? So in this example, there is A, B, C, and there we have A. If you take that to be a substring, wait, let me explain you by writing here. Okay. So here we go. So here is a string given to you A, B, C, A, B, C, D. So if we take this as a substring, it has unique character, right? if we take AB as a substring is nothing but a part of a string that is contiguous. Okay, so if you take this, it is each element, each character is unique. If you take ABC, this is also unique. But as soon as we take ABC, the element in this are not unique. Like A is getting repeated twice. So you have to tell me the length of the longest length of substrings such that element in this are not repeating. Okay, so one hint I can give you from here is that it's in the question that element should be non-repeating, right? If element is not repeating, element should be unique, right? So what kind of data structure should we use? Yesterday we understood in that case we should go with set, right? Set provide the uniqueness. It can help us to check if the current subset it check is contain unique element or not. Okay, so I hope you understood the question and let me know if you didn't understood. I will explain you again. Yeah, exactly, WDR, right? We'll be using a container to store the frequency of repeating character. Exactly. That we can do in that way, but here we will be using a set to check whether element is present or not. It will be doing the same thing, but just you can implement the same thing using different data structure, right? So that's what we are doing. Okay, so what will be our approach? So initially we will be starting from here. Okay, this string is given to you, and these dots are the characters. Okay, so initially suppose this is our current substring. Okay, this string uh, doesn't have any repeating character. So for this index I, what are the options? It like if this character, this index I character will be SI, right? So for this index, we can add it into this same substring if this character is already not present in this substring, right? If this SI is not present in this current substring, we can simply add it because adding it will not be make the thing go worse. Like each and every element in the substring will be unique. Okay. So in this case, if SI is not present in this substring, we can just add it and increase the length of our substring. But what if SI is present? If SI is present, okay. If SI is present, then one thing we can do, like we can move this pointer. Okay. To understand this, let's see. Let's take a bigger example. If you are at this index I, this is SI. Okay. This value will be SI, and you have pointer from this position to this position. This the current substring will denote. It means that all the element in this substring are unique. Okay. So uh, so since SI is present, in this case SI is present in the substring. So what we can do, one more thing I want to tell you, that whatever element we have in this substring, we are storing this each character in a set. Okay. We are inserting all these character in the substring into the set. So whenever we want to check if SI is present in this substring or not, we will check if SI is present in this set or not. Okay. And yesterday I told you set.count function can be used to check if the particular element is present in the set or not. Okay. So since up to now, in this case, SI is present. Okay, SI is present in this set. So what we can do, we can move this left pointer to this position here. So this substring is only from this to this. Since we remove this character from this substring, we have to remove this character from our set too, because set contain the current substring character. Okay, we will move here and again we will check if SI is still present in this substring, in this new substring or not after removing this. If it's still there, we will again move to the right at this place, and again, and after some point suppose this SI is present at this place only. Okay, So it means that when we are moving from this to right, we will be deleting this character, right? So in the term, this si will also be getting deleted from set. So when we come here, so it will be like this is the only set we will have. In this set, si is not there, so this is not the first case. So we can now extend the right pointer to here, and this will be our substring, new substring for each pointer. Okay, I hope you have understood this logic. So just let me know if you have understood. Haven't understood. There will be two cases. Either SI will be present in it or SI will not be present in it. Okay, and we are handling those cases here. If SI is not present, just move to the right point, move right pointer to the right. Otherwise, move left pointer to the right until the SI is not present. And when you are moving this pointer to the right, just make sure you add si, since this is your new substring, right? You will be adding this si in your set. You have to add because this is now part of your substring. I hope you understood. Just let me know quickly so that I can go with coding. Yeah, there is no problem in solving directly lead code problem, but I just want to know there will be function will be defined here. We are starting from basic. So if you want me to solve lead code directly, problem directly, we can do that from tomorrow too. But here right now it will like take some time, right? Just understood the logic. If you know the logic, just you can solve any kind of problem. I would have solved this problem in lead code only, but like you need to find the problem where it is. Okay, I hope you understood this problem. So let's code it. So you are given a string. Okay, you are in this question you will be given a string. Yes, select a string. Yes, you are taking input a string from the user. Let's define as n is equal to the length of this string. This will be using later. Now let's define the left pointer and right pointer. We will be initializing the left pointer of the current substring, the right pointer of the current substring to 0. Okay, then the max length, because we have to find the maximum length of the substring such that all the elements are unique. Yeah, exactly. We are using two pointer approach. So int max length is equal to, we are initializing to 0, and we'll be using two pointer approach since we are using left and right. So while L less than equal to R, this condition we are initializing, or let it be like R less than N. Okay. So in this condition, what we need to check? First, we need to check if the right element, the I here, okay, sorry, at this position, this element is in the set or not. We will check. We will check it here. If S, okay, I have to define set. Sorry. Here in this case, we need to define set of character, right? This st, and here character defines denotes that this set contain characters. So if now we need to check if st dot count sr, we have to check for rth element, the rightmost element, this element. We have to check for this element whether this element is already present in this substring or not. So if the count of sr in set is equal to 0, so what does it mean? It means that the it is not present. So we can add this element. We can just extend the subarray to the right, and we can add it to our answer. So set dot insert, we will be inserting this element r, set dot insert sr. Okay, and we will moving now right pointer to the right. Okay, and okay, done. Now what we will be doing, if this condition is not true, if st, if this sr, if this sr is present in that, so in that case we need to run a while loop, while l as an r, and while it should be st until the sr getting deleted. Until sr is not deleted, we will be we will be moving, like this is what we're doing. Like suppose if si is there in this substring, we will run a while loop and we will check, we will move this left pointer to the right. We will be keep moving this left pointer to the right until si is present in this. If si is not present, we will be doing the same thing what we did in this case. Okay, so up till now we are running if st count, if, count is not equal to 0, we will be running this for loop. S, we are moving the left pointer. See here we are moving the left pointer to the right, this L pointer, and then so that's why this element we have to delete. When we are moving this to the right, we have to delete this element, right? So this is what we will be doing. St dot erase SL. L is the left pointer, right? And we will be incrementing this L. We will be moving this L to this place. Okay, this is what I'm doing. And after doing this, it means that after finishing of after continuing this while loop, or when this while loop get completed, it will be like SR is not there in the substring. So we need to insert SR now. St dot insert SR. The right element is not there because we remove the duplicate of right element right now up to now. So we now have to insert this right element. We need to improve. We need to take the okay, and here also like you inserted it, right? So you need to take the maximum length value. So max length, I will explain you why I'm taking this. Max length is equal to r minus l plus 1. So I'm doing this because when this element is not there, we are adding it to the right, right? We are adding it to the right, and so the size of this is changing. When you are adding it to the right, the size of this is changing, right? So at each and every point, you need to keep track of this size. If size is getting greater than a maximum size, this will be now the maximum size. Okay, so that's what I'm doing. Okay, similarly in this case, after adding this, we will be taking max length equal to max of max length and r minus l plus 1, and then r plus 1 we will go to the next r. Okay, and then in the end we can put into whatever the maximum length is. Okay, let's see if it gives the correct output or not, or if it gives some errors. You do it for the same output, and answer for this should be 3, I guess. Okay, let's see if it gives some error. Okay. Mm, we're missing something. At insert is R. Okay, here I'm missing this. Okay, one more mistake. Yeah, it is giving 3. So let's see, let's try with some other output. What if all characters are same? A. Okay, let's see. In this case, it should give answer equal to 1. And what if all the elements are different? ABC, ABC, ABC. Yeah, in this case, it's okay the same, but what if all elements are different? Let's see if it is giving the correct output or not. Yeah, in this case, it's also working. It giving the correct output 6. So this is complete. So let me know if you have any problem in this. Otherwise, we will move to see. We are calculating max length before implementing R. The reason being is that see before at this present R, this is our R, right? We are in each while loop we are deciding for this R whether we have to include this R or not. So if we are done with this R, if we decided for this R, this should be included or not, then we are done. We are done. This is the max length. We don't need to at first increment this R plus 1 because this is our current observation point. We are decided for this that this should be in our segment substring or not. We are not clear for this. For this, we will see again in the next iteration that whether this element is present in this or not. Again, we will do the same thing. We are doing this for R. This R is there, which for which we are getting sure that it is the part of a substring. We are not sure for this. Okay? So that's why we are doing for only R. If it is there in the substring, we are just proceeding with the while loop, moving left pointer to the right. Otherwise, we are just adding it here. Okay. I hope your doubt is cleared. If it's still there, just let me know. Okay. Let's see if it works for this output. Somebody of you have given this output A, B, C, B, B, A, H, I, A, B, C, D. Yeah. Let's see if it works or if it gives some error. It gives 6. Let's see 6 is the correct output or not. Yeah, it is correct. Like from starting from C, this is correct. Starting from C, D, B, A, H, I. It's giving the correct output. Hope you understood this. Or if you want to try for some other cases too, just let me know. Otherwise, we are moving to the next problem. Okay, let's move on to the next problem. The next problem is this. We are moving with this problem. Okay, intersection of tools array. I'm moving with this problem just because this problem is very important, like the how we will be using the two data structure and taking the help of using it as per our need. Okay, and this will be using both map and set. So this integers, okay, this tells that you are given two array. This question, like nums1 and nums2 array are given, and you have to return new array that contain the intersection of both the element. Like it means that for some some element will be present in both first array and second array. You have to fill those elements which are present in both the array, and each element in the result must be unique. So, for example, okay, let's go here. So, for example, in this array, this is given to you. Okay, this is the first array. 2, 1, 2, 3, 4. This is a secondary. 2, 2, 4, 5. So what is the common element in this? The common element in both the array is 2. You have to return 2 and 4. It's not like 2 is getting repeated twice in both. You don't have to repeat. This should be unique. Each element should be unique, and you have to return the intersection element. Uniqueness, unique intersection element. That should be the exact word. Like you have to return unique intersecting element. So let me know if you know how to do this, or we will move. Yeah, definitely we can print the substring, Rajiv. Yeah, some of you want to show the full code. See, this is the full code. I don't know if it is like, this is the main logic. I hope this is clear. If you have still any doubt, just let me know. Yeah, Rajiv, we can print the substring too. In the substring too, if we want to print the substring, we have to define it like max length, and you have to define the condition. If this value is greater than max length, so if I have to modify it, let me modify it. Okay, so it will be like if my condition will be if max length, if current length r minus l plus 1 is greater than max length. Okay, if it is greater than max length, then string sub str will be equal to s dot sub. Sorry, this is the name of the function. So the new string will triple s. Okay, so it will be s dot sub str starting from l to length r minus l plus 1. So here it will be getting stored. So maxing into the maxing pool is equal to r minus l plus 1. Okay. How this is clear. This is how we can print the new substring. Okay. I could have just shown you here, but like I need to change it here too. Time is running. We have to cover a lot. So I hope you understood this. Okay. No, see, two array is given to you. So you have to find the intersecting element. You don't have to compare them. So like you can't say it to be array comparison. Like you don't need to compare them. Just you have to find the unique intersecting element and return it in the array. Like this. So do you have any idea how we can solve this problem? Just let me know quickly so that I can start with recursion and backtracking. Okay, let me proceed. We can use, see, for the first array, we will be traversing the first array. Okay. For all the element of this array, we will be making a map. We will be inserting this element in a map. Okay, all the element of the first array. So up to now we have a map that contain element of array 1. Okay, and when we are iterating in the second array, we will we will checking we will keep checking if this element is present in this map or not, if this element is present or not. If this element is present in map, it means that it is present in the first array, so this is an intersecting element. If this, for this element again, if it is present in this map or not, if it is there, it is again in the first array. If it is not present in the map, this means that this is not in the first array, this is not the unique element. So see here, suppose one sorry, so one problem here could be, suppose 2 is there in the first array. Okay, so 2 will be there in the map 2, and now here we are having 2, here we are having 2. 2 is there, check if it is there in the map or not. It is there, so it will add 2 into our answer array, right? Again, for this 2, it will check there in the map or not. If it is there in the map, it will again add answer. Okay, this will be like, but we, in the final answer, we need to tell this unique element. This 2 should be only one time. Okay, so what data structure should be used at this case? Since this we need unique, we can insert this element, these element, like if this element is there in the map, we can insert this element in a set. Okay, if this element is in the set, if this element is in the set, then it means that this, in the end, we will be traversing this set and we will be taking out all the element of set. All the element of set. Okay, and that will be our answer. I hope you understood the logic. We can proceed with the code soon. Okay, just let me know. Yeah, we can go with set to store. Yeah, true. We can use set for looking up to, but here I'm just using that. Like, it's all, like, a problem can be solved in many ways. No. We are not checking value. See, if we are inserting, when we are inserting this to into the map, it means that we will be doing like map mp is the name of the map to plus plus plus, map to plus plus, so that its value won't be zero. So if I came at this place too, then when I will check map to, I have to check map to is not equal to zero. This will be my condition. If this is not equal to zero, then it means that it is already present in the first array, right? So that will be the condition. Like, we won't be comparing the value. It could be anything. It could be 1, 2, 3, 4. But if it is not zero, it means that it is there in the first array. That's what we want. No. Who said looking up and set keeps open? It takes O of login time. Both will take the same time. There is only different complexity. It will return only two. Akhilesh, in your example, 2, 2, 3, 4, 5, 6. Since C, we have to return the only unique intersecting element. So it will return only 2. And Karthik said, if you are trying to look something in set, it takes login time. It works on a binary search arbitrary, and for that it takes login time. In some cases, if you are using another set or something, it can take off one time, but that's rare. If you are using that on lead code or somewhere in code sources, some of the test cases might fail. You won't be able to pass because the test cases would be designed in that way so that it can, if you use another map, it will fail. In worst case, it can go to O of n. So if you use ordered set, it's always log of n. So it's, to be on safer side, just use set, normal ordered set. I hope you understood this, so we can move with the coding part of this. So let's move on to the coding part. Okay, I'm removing this. Okay. Hi Karthik, from tomorrow we will be solving lead code problem. It's not possible in the mid to change. Okay, so in CN, just try to understand the logic. Everything is secondary. In N, this denote the size of the array, and we will be declaring two array. In V1 will be the first one, and vector in the size of the second one, V2, second vector. Now we will take input from the user for first array, G plus, sorry, C1 V1 J. Okay, now 4 and J0 J less than J plus plus. C in V2J. Okay, now we will declare a map. You can go with set to see on time complexity basis, it's not going to differ. Okay, so it's your choice. You can go with both. Here I'm going with map. Name of the map is map. It will be pointing from key integer to value integer. Okay, so 4 0 J less than J plus plus. I will be inserting the element of this V1 array in the plus. See, this is how I'm inserting. I'm inserting and doing plus plus. So if element is there, the count of that element will be 0. Now I will make a set of integer st. Okay. So now I will move to the 4 and j is equal to 0. J and let's set in j plus plus. And I will check if this v2j, this element, jth element of second array is present in the map or not. So if this is not equal to 0, okay, if this is not equal to 0, this means that this element is present. We can insert this element in our set. I hope you understood why we are using set here, not an only array. Because in our array, if we is getting 2 times the repeating second array, it will get into our answer. In set, it guarantees the uniqueness. Okay, so that's why we are using set. And the syntax for accessing element of set is this st, and we can put it here x. This will print all the element present in the set. Let's see if it gives some error or okay. So let's define the size of the array 5, 1, 2, 3, 4, 5 the first element, and let's take 2, 2, 2. It should give 2. Okay, I missed the semicolon. Again, here is some error. See, unique intersecting element is 2. I can tell you if I remove seed of 1, 2, I'm using 3. In this case, answer should be 2 and 3. See, 2 and 3. If I make all same, the first way, 2, 3, 4, 5, all should be there. 1, 2, 3, 4, 5 is all intersecting. Okay, it doesn't matter. I can make it in reverse order to 5, 3, 2, 1. Yeah, it is working. See, some of you are asking why we are using set. So see, I told you before. See, suppose in the first array there is a number 2. So we will be inserting this 2 in the map, right? And in the second array, suppose we have here we have 2, here we have 2, and you are inserting this element in an array. This is your answer array. So you will go at first at these two and you will check if this is present in the map or not. Since 2 is there in the first array, it will be there. So we'll be inserting this into your answer. Okay. Again, we will go at these two. We will check if it is there in map or not. It will be there in the map, right? So again, you will be inserting 2. But this is what this is not. This is something we don't want. We want if 2 is a repeating number, it should be only one time. 2 or 3 2 shouldn't be there. Each element should be only one time. So instead of these two, it should there should be only one two. That's why, since we want to maintain the uniqueness, instead of this array, using it array, if we can use this set, we can just maintain the uniqueness. Just keep inserting two as many times you want, but in the set it will be only one time. So that's why we are using set, not array. I hope. Just let me know if you have understood this. Okay, so I hope we are done with this. Let's move to the today's topic, which is recursion and backtracking. So today we are going to study about recursion, backtracking, and bracket problem. Okay. So what the recursion is? So recursion is basically a function that calls itself to solve a problem. It's like, you can think it like I wrote it here in very simple language. You will get the slide. So just go through it here. It's like you are given a problem. It's like, suppose you are given a problem. This is a problem. This is the problem. Okay? This is the problem you are given. Take it some mechanical work. Okay. You do a part of this problem and then give it to your friend to just do a bit, some part of this problem. You do a part of this problem. Okay. Then your friend do a part of this problem and then give it to some other friend to do the part of this problem. Then again, you again gives to someone else, again to someone else. It's like this. In the end, whatever he has done, he will return to this. Whatever he has done and whatever he has received from his friend, he will return to this. So what in the end, at this point also, whatever he had done and whatever he had received from his friend, he will receive this. He will receive it to. He will send it to them, him, and again in the end. So it would be like in the end, problem would be solved. It's like I'm not solving the again problem. I'm solving the part of problem, and I am just transferring the sub problem of this to my friend so that he can do. The friend will be, this will be a function, and this will be a function, and this will be a function too. Okay, so let's go into the PPT. So I wrote this thing here. It's like this only, recursion is this. It's like you are calling function calling itself to solve a problem. So in real life, you can imagine it like you got a gift. Okay, there is some gift in the box, but there are many boxes like this. You have a bigger box, then smaller one, then a bit smaller, 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 and the end in the smallest box you have a gift. And at first, all the boxes are closed. So what will you do? At first, you will open the bigger box. Then you will go to the a bit smaller box. Then again you will open the bit smaller box again and again until you get to the gift in the smallest box. Okay, then you take out the gift, you will close the smallest box, then you will close the box which is just bigger than smallest box, then again bigger, and in the last you will be closing the biggest box. So it's like this is how you enter into a function. At first you will have a bigger problem, and then you entering into smaller problem, again smaller, and in the end you have the smallest problem that you have solved, and after that you will be returning something from the smallest to the biggest. Okay, I hope this slide will help you to understand this visualize. So recursion have two part. The base case. The base case, it means that in the end, in this case, you get the gift. Like after that point, you know you don't have to call another function, right? Like in this example, for the friend in the end, this problem is so small that he can solve this problem. He don't need to send it to again to any other friend. Okay, so we can just this is what the base case mean, and all these are recursive call. This is recursively calling this function, this is recursively calling this function, and this again, and whatever whoever the solving all the problem on his own, that is the base case, that's the smallest. Okay, I hope you understood. This is a bit tough topic, but just be informative, like be attentive. You can just do it, it's easy. So here I told you recursion has two part: the base case when to stop calling itself, and the when recursive case when to call itself again with smaller problem, and it keep repeating until the case is hit. Okay? So now the question with us is, what is backtracking? Backtracking is simple, like trying try all the possibilities you can do, and if something doesn't work, just undo them, come back. So we can understand it like this. So every one of you have might solve this kind of puzzle, like there is a mouse in the maze, you can say it like this, like there will be some wall here, you try all the possibilities, and this like this. Hope you understood this kind of problem, and you have to enter from this place, and you have to like exit from this. In this, what you do, you just go at a place, you try going this side. If this side doesn't work, you just come back, because you see this there isn't any way. So in comparative programming, you can say there isn't any solution. You just figure it out, and then you will come back to initial point. Then again you will move to the right, and you will check all the possibilities. If either at this there is a possibilities of moving to the right, or you can move down. You will go here, just check it the possibilities, and if it doesn't work, you will come back again. You go here, you check all the possibilities. If something is not working, just leave it. So this is how it will work, and in the end you will get your solution of your way that will move to the this point. This is what backtracking is. Just understood this, like this is so simple. Just try all the possibilities. If something is not working, just come back. Yeah, don't worry, we will be sending you the PPT. Yeah, exactly. It's a rat maze problem. You can see rat maze problem can be solved like NP problem. That's a very NP hard problem. This all like can be solved. Recursion and backtracking is like one of the toughest topic of this competitive programming. Yeah, it uses brute force approach to sure, but it's involved a lot of thinking. You need to know a lot in detail about data structures, how we will be using it. So it's very important. Yeah, time complexity will be increased, but do you have just think, do you have any other solution? In this case, what we will do is it's not like the size of this maze will be something like 10 ki power 5, it will be like 10 or 20, right? 10 or 20, it will be something like this. So in the interview or any at any platform you will see a lead code or interview it, whatever, it will be like this one and will be so small so that it can form. If the time complexity of recursion is exponential, like 2 raised to power n or something, so n can't be bigger. It could be somewhere around 12, 13, or 14. I guess up to 18 you can go on code forces, the solution will work. If it is greater than 18, then it might be PLE. So it will be like lesser than that, only like 15 or something. See, in recursion here, we can't use dynamic programming. In recursion, I will show you the problem that we are going to use. In this, we can't do dynamic programming, but in generally we do in order to optimize a solution, like, in order to make it better. In this case, the backtracking one. In this, we can't do dynamic programming. We can't go by dynamic programming in this. I hope you have understood this. Generally, we do dynamic programming when we are doing recursion or something, but in this case, we can't. We will understand it later. See, this, Prabhu, if you're talking about optimal solution, this is optimal solution, and there isn't any optimal solution. Like, how can you track in this case? See, recursion is a brute force approach, complete brute force approach. You can just optimize it using DP. But in this case, in the match React maze problem, in problem, you can't use DP. DP can be used in some other cases. We will see in the DP lecture. Okay. Okay. So let's move on with the problem. I hope you will understand it there. How can't we use it? Okay. So how it is there? How does computer handle recursion? It uses a stack. It's a pile of book. So let me explain this here. So you have a function here. Okay. This function is there. This function is calling a smaller function. This again fun calling a bit smaller function. This again a bit smaller function, and like this. And suppose this is the base case, it will be turning it here. So when we are calling this function in the memory, in the operating system, it's like a stack created. So let's name the function f1. This is f2. This is f3. This is f4. This is f5. So at first, the user will be calling this function. Okay. So it is a stack. So like in the memory, it's why it will declare in this form. F1 will be called. Then F1 will be calling this F2. Then F2 will be called. F2 will be called here. And in stack, it's a FIFO, FIFO data structure. It means that first in, first out. Suppose this came first, it will remove first from the stack too. If something is coming, so it will be like if something is coming here like this, it's coming after this, then we have to remove some element from here, we will be removing this element that came last. Okay. And in the queue, it's like first in, first out. Whoever come, sorry, it is LIFO, sorry, it's LIFO. Last in, first out stack is. And the queue is FIFO. The first in, whoever in first will exit first, and entry will come from here, and exit will go from here. The first in, and in stack this is like this. So F2 will be here, followed by F2 is calling F3. F3 is calling F4, and in the end, we are going with F5. So this is how the stack, the function is getting arranged in the stack. This is how it get on the operating system, and it's like it's not. If you haven't understood it, it's completely okay. I just told you the memory management of this. Okay. Yeah, I guess I don't remember exactly. I guess, but DB is there. I guess. No, don't go detail of this stack thing. No? It's like very difficult. It's not very difficult, but like it's not relevant to whatever we are learning right now. It will be. It might be the chance that it might interviewer might ask you, but that's very rare. So let's move to the problem. We have this problem. So the problem is that you are given an array of distinct integers. You have to return all possible subset. So let me explain what problem is. Okay. So I hope you understood the problem. Just give me a second. So this problem states that there is some element like you are given a integers, you are given an array in that some element is there and all the element are unique. So what is like you are given an array. Let's suppose this take a smaller array. Okay, you are given array 1 and 2. So what could be the possible subset of this? First subset will be empty. We won't take any element. Second possibility is that we take only one element, first element. Second is that we take only this second element, and other possibility is like we take this both element, one and two. So these are four possible array, and you have to return all possible subset. I hope you understood this question. Like you are given this, and you have to return all the possibilities of this. So let's see the example for n is equal to 3. If you are given this subarray, okay, 1, 2, 3. The first subset is that generate all the possibilities. Subset means for first is like 1, we take only 1. Second possibility is that we can go with 2. Third possibility is 3. Next possibility is we can take 1 and 2 together. Next possibility is 2. We can take 2 and 3 together. Other possibility is that we can take 1 and 3 together. And one more possibility is that if we take all together. So these are all the possibilities in case of this. So you know the number of possibilities if there are n element, if there are n element, then there will be 2 raised to n subset, including the empty subset. We haven't taken the case when the set is empty. So if it is 3, so there will be 2 raised to power n equal to 2 raised to power 3 is equal to 8 subset. 1, 2, 3, 4, 5, 6. 4 and 4, 8. Yeah, here we have 8 subset, and in this case, we have 4 subsets. It's n is equal to 2, 2 raised to power 2 is 4. So this is 4 subset. So this is what the question is. Okay. So now let's see how we will be solving this question. So for this index, if we are at this index, what are the choices with us? Ith index, what are the choices for this index? We don't care about next index right now. What are the choices? Either we can take this element or we don't take this element, right? If we take this element or if we don't take this element. If we take this element, then this element will be in our subset, right? AI. And again, and then our problem is that we are done with this. We are done with this subset. Okay. Now our problem is that we will move to next I plus 1. Since we decided for this, we will go for I. So now the problem is the same problem. This is a problem with this I. Now we have the same problem, but I will start from this position. Okay. This is the same array, but now I will start from this I plus 1 position. And now again, we will have two condition whether we have to take this new AI, which is equal to I plus 1 of this, or we don't take it. If we take it again, this AI and new AI will be in our subset, and otherwise we don't. And what if, in this case, if I don't take this element? If I don't take this element, the subset will be empty, right? And but this subset will be empty. There isn't any element right now in the subset. We will be moving to the next subset, next I plus 1, which is equal to at this position, I plus 1. And again, we will be starting our problem just as this I, we are just like we are starting from now this I. So this is how recursion is coming into play. Like this is a problem we solve for this I, and we give this part to our friend to solve it. Then again, our friend, which is at this position, will solve for this I, and again it will send this part to its friend. Okay. So what will be the end case? If this friend will give to this friend, this will give to this will give to this, and this will continue. Okay. It will continue until we came at an end at this point. At this point, what will happen? There isn't any next element. So this is the base case. Base case will be this when I index is equal to size of this array. This is size is n. If I is equal to n, it means that there isn't any other element. So we need, this is a base case. With it means that it don't need to call any other friend or function now. So let's implement it here. Let's implement it in code and let's see if it's working, how it is working. Okay. So for this, we need an integer v n size of an array v n we take input vector info in j0 to 0, j less than n, j plus plus. Okay, and inserting this element. We are taking this input from the users. Now we will have two. We will have two vector. We will see here. Let's make a function. This is how we make a function. The return type in this function will be void if in index. The argument will be index, the I, which we will be passing, and the array from where we will be taking this from where we will decide whether we have to take this or not. And if we are taking this one, this current one, the current is this current subset. For this current subset, we are making another vector to store the current subset. I know it will be difficult to understand, but just see what I'm doing, and after this class, just try to go through it, try to understand, just write everything, then you will understand. Then again, I'm making vector of vector to store the answer. Now, what could be the case if we are taking this element? If we are taking this element, see, if we are taking this element, we are inserting it into our current subset. Okay, so if we are taking this element, then we will, let me insert this in the current pushback dot v index. Okay, correct. Now I am inserted this. Now I will call this function again with index plus 1. We are now calling my friend with index plus 1 to solve this problem. Okay, with the argument will be the same, the rest of the argument. And now that my friend will solve the problem, it will return something. Okay. Now what if we don't, what if we don't add this element? There will be two questions. Here we are adding the element, here the elements were added, now we are removing the element, so that in the current the element is not there. So this is the case when element is not there, we are just giving it to the friend. I didn't take anything, just take my friend, just to the next one. This is what it means here. Okay, so yeah, so this is done. We will return the function, and the base case is that when if index is equal to v dot size. If v dot size, then we will be inserting answer dot pushback current. The current is the current subset. If we are the end, whatever subset we have, that we will be inserting in the answer. Okay, this. So let's call the function. Let's see if it is working or not. We need to define before calling the function vector int current vector to vector. Vector to vector is nothing. It's a 2D vector. It's a vector, and in that vector, see, vector to vector is nothing. It's like you have this a vector. Earlier a vector is like this. We have some element here, here, and here. It's like this. But now vector of vector is here, instead of a single element, you have a vector. instead of this next element, you have a vector. So it's like a 2D vector, and you can place element here, 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 here. Okay. So it's like it's a 2D vector, nothing. So vector or vector type int. Let's type it answer. And now let's call the function. We are starting from 0 index. B is our array, and then current being current and answer being answer. Okay. So now let's print the answer. This will store the answer, the all generated subset in this answer. Okay. So let's print it. For answer J is the answer dot size J plus plus 4 int 4 int I is equal to 0, I less than answer J dot size I plus plus, printing the element of the subset. So answer G I is this. Let's see if it works or if it gives some error. So for we will let's first check for array of size 2. Yeah, see, it's working. It giving all the possible subset 2, 1, 1, 2. Let's check it for 3. 1, 2, 3. Yeah, see, it is giving all the possible answer. So let's check it for 5. 5. Really, it will be, we will have a lot of solution. So let's see. Yeah, you got all the possibilities for 5C. 1, 2, 3, all this, many possibilities. So let me see if we have it out. Yeah, exactly, Rishu, you are correct. See, this means that you are using this. This is a pointer. This means that we are passing it by reference, not by value. It means that we are just passing the address. If we do pass by a value, it will give you a TLE because every time a copy of the array will be created. Yeah, empty subset could be here too, but we aren't considering the case in this. It could be, it is there. So you know the empty subset is there. So if you want, just add it here, empty array in this answer. So I hope you understood this, and we will be wrapping up the session. You can try other problem on your own, and if you have any problem, like we will discuss this tomorrow. Okay. Okay. So goodbye. See you tomorrow. Yeah, we will send you the PPT. Don't worry. Just go through the PPT. I wrote exactly everything, whatever I told you in the PPT. PPT is very clear. Okay, then bye bye.